Good morning, ma'am.
Yes. So, what's the lesson we discussed in the last class? What's the chapter name?
Atomic structure, ma'am.
Very good. It's an atomic structure. Okay. So, what's the exact topic we discussed in the last class? Any one of you? What's the last topic we discussed? Anyone remember? I think it's photoelectric effect. Am I right?
Yes,
We
madam. I
finished
do remember.
photoelectric
Yeah.
effect.
You
Yes, sir.
said
Yes.
Rutherford, all those Busan, all
Yes,
those
sir.
stuff, and then went to photoelectric.
Yes, sir. Okay. So, yes, photoelectric effect. Before that, I'll ask you some basic questions, students. Yes, who found the electron? Who found the electron? Yeah,
Goldstone.
Goldstein. Goldstein found actually proton, electron.
J.J. Thomson.
Okay, electron is J.J. Thomson. Based on which method he found the electron?
Cathode ray experiment, ma'am.
Very good. It's a cathode ray experiment. Yes. Okay. Who found the neutron? Yes.
James Chadwick, ma'am. James Chadwick.
Neutron. See, proton is only a
Goldstein.
Goldstein is for proton students. Neutron is actually discovered by Chadwick. Okay.
James,
Neutron. Neutron is discovered by Chadwick based on the bombardment of alpha particle with the lighter elements. Okay, this is the right answer. Goldstein. Goldstein is actually he found the protons based on the anode ray experiments. Okay. Yes, good. Then how many atomic models we have based on Genesis? We have how many atomic models?
Bose atomic model, ma'am.
Very good. Bose atomic model,
Rutherford's model
Rutherford atomic model. Very good.
and the plum
Quantum
pudding.
model.
Very good. So the starting one is actually a plum pudding model, which is J.J. Thomson. Then comes Rutherford, then Bose model, and finally, what's the last model?
Quantum model.
Very good. It's a quantum mechanical model. So I think photoelectric effect is over in the last class. We just started Bose model. So we'll come to the Bose model. We'll start with the Bose model. Yes. Then after that, okay. So this electron is having an only an particle nature or any other character it has? Yes. This electron is having only a particle character or any other character it has?
It has wave nature, ma'am.
It has a wave nature. So it's a dual character or the dual nature. So the electron will behave as well as particle as well as wave. Yes, it can behave as waves also. Okay. So which experiment is helpful to show the particle's character? Do you remember? So Thomson pudding is very a simple model. It's actually a failure model. So the structure of atom is not totally correct. Then comes Rutherford. The Rutherford's point of view is most 90% is correct. Most of the atom have empty spaces. Then the nucleus has a very small region. That and all a very correct part when it comes to the atom. Yes. What is the disadvantages in the Rutherford model? What's the problem in the Rutherford model?
He failed to explain the properties of electrons, ma'am.
Okay, he fails to explain the property of electrons. The very important thing, what he is saying is the electrons are revolving in an orbit. So, according to the Max Planck, if any charged particles revolving in an orbit, it will release some energy and it will falls into the nucleus. So then the atom is unstable. So he didn't explain this part. He didn't explain much about the orbits. So next, Bose is coming. So Bose said that the orbits are fixed orbits. The electrons are revolving in the orbit. No, that orbit is a fixed orbit, and there is no energy loss or energy gain while revolving in the particular orbit. The electron will not lose its energy or gain its energy. That's an important one. That Rutherford is failure to explain that point. Yes. Then, okay, Bose model. So, what are all the important postulates in the Bose model? From that only we have to start. first thing, it is only applicable for single electronic species, right? Single electronic species. What it mean by single electronic species or one electron species, student? Do you remember?
Nice, ma'am.
Yes.
Hydrogen and lithium 2+.
Lithium 2 plus. Very good. So hydrogen in the neutral state itself, it has a only one electron. Bohr's model is applicable only for the one electron species. So for example, if you take an helium, the helium atomic number is 2, it has a 2 electron, so it's not applicable. So what they are doing, they are ionizing it to make an He plus. So He plus has a 1 electron. So the Bose model is applicable only for the 1 electron species. Then we said the electrons are revolving in the fixed orbit. There is no energy loss or gain. So the atoms are more stable. The electron will not fall into the nucleus, which means the atoms are more stable. This is his concept. Then the electrons will revolve in a fixed orbit having nh is equal to 2 pi. Like nh 2 pi in the sense the angular momentum should be fixed. I have explained about linear momentum and angular momentum. Linear momentum is your mv, mass into velocity, and then angular momentum is mvr. Okay, it's about the radius. So the electrons will only stay in the orbit where the h by 2 pi is constant. For example, if you take the first orbit, it has 1h 2 pi, and the second orbit has 2h 2 pi. Okay, so mvr is equal to nh 2 pi. The angular momentum is equal to integral multiple of h by 2 pi. So the electron will stay only in that orbit having nh 2 pi. This is an important point Bose has said. Okay, then okay, for example, you have one electron in the first orbit. Okay, let's consider we have one electron in the first orbit. It has to move to the third orbit. So what it will do usually, whether it will absorb energy or it will release energy? Yes, students.
And it will absorb energy.
Very good. Yes. So the electrons in the first orbit, it's supposed to move to the third orbit. So that means it has to absorb energy. So it's in the third orbit. Again, it has to come to the second orbit, means what it will do?
It loses energy.
It will loses energy. And as we said last time itself, I have explained. So the ground state is a most stable state, because ground state you have an less energy. Energy is inversely proportional to stability. So whenever an atom in the lower energy states or the electron in the lower energy states are more stable, so it will prefer in the ground state. Okay, so next is about just formulas. Only formulas based things, like based on the Bohr model. You have many formulas. Derivation is not needed. Just I'll write down the formulas, and then based on that we will do some problems. So formula based on Bohr model. Okay, first one we are going to see for radius of orbit. Radius of orbit. Okay, so to find out the radius of orbit, see, all these are applicable only for the single electron species. Bohr's model is totally applicable for the single electron species. So the value is Rn is equal to this Rn in the sense nth orbit. Okay, this denotes orbit. So Rn is equal to 0.529 n square divided by z angstrom. So angstrom is a unit. You know that 1 meter is equal to 10 to the power of minus 10. Sorry, 1 angstrom is equal to 10 to the power of minus 10 meter. So the radius of nth orbit can be calculated like this. For example, I want to calculate for the fifth orbit, means then our fifth orbit is equal to 0.529 5 square divided by z into like angstrom, which is a unit of radius of the orbit, angstrom. So this is the formula you can use for it, radius. Then for example, they are asking in radius ratio. So this is your r fifth. and you are calculating the R first. So if they are asking a radius ratio means it's very simple. Like you can do R first divided by R fifth, or else R fifth divided by R first. So that's a formula. Okay, this and all very important when it comes to JE or Neet. So R1 divided by R2 is equal to N1 square divided by N2 square into Z2 divided by Z1. Just I am taking the first radius, like R first means first orbit radius and then second orbit radius. Otherwise R1, R2 may be any numbers. So it may be an any orbits. So just taking a radius ratio, and the formula is N1 square divided by N2 square into Z2 divided by Z1. So this is the formula. We can use it for the radius ratio. So from this, it's very direct. Radius is directly proportional to n or indirectly proportional to n? Yeah, just tell me from the formula. Radius is directly proportional to n or inversely proportional to
And
n?
directly proportional.
Yes, radius is directly proportional to n. And they are saying radius is inversely proportional to z value. What is a z? What is a z denotes here? N is your orbit number. What is mean by z, students? It's an atomic number. Atomic number is mentioned as z only. No, it's simply an atomic number. Okay, z value is your atomic number. Okay, so what's the radius formula? It is 0.529 n square divided by z angstrom. Okay, this is the formula for radius. Then we'll comes to the next formula, which is the velocity formula. So again, the velocity formula, we'll go directly into the formula. Velocity of the radius. So velocity of the radius is equal to, let's calculate for nth orbit, Vn is equal to V naught Z by N m by S. So meter per second, the value of V naught is 2.188 into 10 to the power of 6 m by S. Again, if you see here, the V velocity is directly proportional to atomic number and then inversely proportional to n. Based on this, you may have some problems. Okay, so the relationship, make sure you are very clear. From the formula, you will get it. It's very easy. Yes, then how we can write the ratios? V1 by V2 is equal to Z1 divided by Z2 into N2 divided by N1. That's a formula. So just from the ratios. So just compare it, then you will get the ratios. It may be of any number. It's not like first orbit or second orbit. You can relate the even fifth orbit with the seventh orbit also. Is there any doubt why it comes like this, students? V1 by V2 is equal to Z1 by Z2, N2 by N1. Is there any confusions here? Are you people clear or not?
Yes, ma'am.
Clear, right? See, otherwise I'll do for one. See, let's take V as a V1 so that V naught Z divided by, let's consider this as an N1. Okay, and V2. So V2 is here, again a V naught, then Z2, Z1, Z2 divided by N1. So what I'm doing? I'm dividing V1 by V2. So that is what your ratio. So V1 by V2 is equal to, what is our V1? It is V naught Z1 divided by N1 divided by V naught, then Z2 divided by N2. Z2 divided by N2. So this and this get cancelled. If it comes in the numerator, reciprocal. So do reciprocal. This is Z1 divided by N1 into N2 divided by Z2. So this is what I wrote as in this formula. So V1 by V2 is equal to Z1 divided by Z2, then N1 divided by N2 divided by N1. Hope it's clear, right? Is there any doubt in the ratio part? Okay, let's move to the time period. What's a time period? Have you heard about time period? Time period of electron? Yes?
No, ma'am.
No. Okay. So next one is time period of electron. It's nothing but it's a time taken of electron to complete one revolution. What's the time period? It's a time taken by the electron to complete one revolution in orbit. Okay, this is what the time period. Again, for that we have a formula. So time period is equal to, let's do for the Tnth is equal to 1.5 into 10 to the power of minus 16 n cube divided by z square. So this is a formula. Again, if you take a ratio, so the ratio will be Tn by T2. The time period 1 and time period 2 will be equal to n1 cube divided by n2 cube into z2 square divided by z1 square. So the derivation is not important, students, just you have to memorize this formula. So there is no other way for this. So memorize these formulas. All these are very important. You will be having, definitely you will be having some questions. Oh,
Suppose the electrons in the outer shell, will it take more time to complete one revolution?
yes, sir, definitely.
The inner shell, the innermost shell will take less time.
Yeah, sir, yes.
Okay.
Yes.
Right.
Okay. See, next we'll go with the one question. So calculate the radius. They're asking a radius ratio. I'm simply write it RR. Radius ratio of second orbit of helium plus ion and third orbit of beryllium 3 plus ion. This is a question. So from this you have to solve what they are asking, students. I'll give you the formula. What's the formula? R1 by R2 is equal to N1 square divided by N2 square into Z2 divided by Z1. Okay, yes. So how can we solve this problem? Any one of you? R1 by R2. They are asking radius ratio. We should find the value of R1 by R2. So let's take, you can take helium plus as a first one. Let's consider the helium plus as a first one. Okay, so tell me the value of N1 for helium.
Helium atomic.
N is your orbit. They are saying that second orbit of helium plus. That means the N1 value should be, the N1 value should be 2.
2, ma'am. Then n square is 4.
Yeah, very good. It is 4. Yes, okay, super. Then what is the Z value? Z1 value for helium? That is also 2. Atomic number simply. Correct. Then let's do the same for the beryllium 3 plus ions. So Be 3 plus ions. The
Ma'am,
N value? Yeah, tell me.
beryllium 4, ma'am. Square
Okay.
number 16.
Very good.
N2.
The atomic number of beryllium is 4 and the N2 value as it is given, it is 3. So just substitute this value. What is your N1? 2 square divided by what is your N2? So here it is 3 square into Z2 is your 4 and then Z1 is your 2. Okay, so what's the answer? Yes, do it and tell me. Simple calculation only, right? Yes, students? The answer is 8 by 9.
Ma'am, in that in denominator it's 3 square, ma'am.
Yeah, it is 3 square. Sorry, I made a mistake. It's a 3 square. So the answer is 8 by 9. Is there
Ma'am,
any doubts, ma? Yes?
no, ma'am.
Okay, I think everyone got the answer, right? 8 by 9. Okay. Next, let's come to energy of the
Ma'am,
electron. Yes, yes.
ma'am, the ratio is 8 is to 9, ma'am.
8 is to 9. Yeah, very good. Super. 8 is to 9. Exactly right. Okay. So I think we'll go ahead with the one more problem based on the velocity. Okay. Yes. Based on the velocity ratios. So the question is, if the velocity of an electron in first orbit of hydrogen atom is v, they have considered as a v, what will be the velocity, of electron in fifth orbit of beryllium 3 plus ion? Okay, beryllium 3 plus ion. This is our question. I'll give you the formula. I want you people to try and give me the answer. Okay, so what's the formula? It's v1 by v2 is equal to z1 divided by z2,
Z2.
yeah, n2 divided by n1. So let's take hydrogen as your first one, like a v1. Then let's take a be3 plus your second one. Okay, so yes, what's an n1 value? N1 value for hydrogen is how much?
1, ma'am.
Yes, very good, it is 1. So what is an z value for hydrogen?
1, ma'am.
Yes,
Also,
z value is again 1. Okay, very good. So what is the
For
v1
beryllium,
value?
4, ma'am.
Yeah, very good. See, they have said that V1 value as a V. Okay, we have to substitute V1 as a V now. So V1 is equal to V. Then for a beryllium, let's take N2 is equal to, what is our N2 value? 5.
5.
Ma'am,
Yes. Yes.
ma'am, one doubt, ma'am.
Yeah.
Beryllium 3 plus lost 3 electrons, ma'am.
Yeah.
We have 4. We have 4. Is its atomic number is 4, ma'am. We
Yes.
lost 3. Get only 1, ma'am. How?
Yes.
5, ma'am.
How you are saying how it is a fifth orbit?
Yes, ma'am.
See, whenever an atom absorbs electron, it will move into the fifth orbit, or even it will move into the eighth orbit also. It is not, I'm not representing here the ground state. It's not a ground state. If an atom, even the hydrogen is staying, the electrons in the hydrogen atoms are present in the first orbit. Am I right?
Yes, ma'am.
But once it's absorbed energy, the electron will excites into even the 10th orbit also. Whenever an
Okay, ma'am.
electron absorbs energy, it will move into the higher energy state. But in the higher energy state, it will stay only for 10 to the power of minus 8 seconds. This very, very less time. Again, it will comes to the ground state. Here we are talking about the excited state configurations.
Okay, ma'am.
Yes. So Z value for a beryllium is 4, Z2, and we have to calculate the V2 value. They are asking to calculate V2 value. So let's substitute. So what is our V1? V1 we took as a V, and V2 actually we don't know. Then the Z1 value is how much? It is 1. And what is your Z2? Z2 is your 4. Correct. Then what is your N2 value? N2 value is 5. And what is your N1 value? Which is
1, ma'am.
yes, 1. So let's take, as we are finding the value of a V2, let the
Ma'am,
V2, yeah. What's the answer, ma?
5 by 4.
5 by 4. Is it 5 by 4? Sure.
Ma'am,
4 by 5, no? Ah,
reciprocal பண்ணா 4 by 5 into V வரும் ma'am, V2 ஓட வேல்யூ.
ah, 4 by 5 it is, not 5
V4
by
by
4, right?
5 is equal to V2, ma'am.
Okay ma'am.
Okay, yes. So I'm taking the V2 into this side. So let's take the 5 into this side, means it will be an V
4 by
divided by 5. Yeah, yes. 4V divided by 5. So this is your answer, final answer. So like that, based on the radius ratio, you will be having, or the velocity ratio, the ratios kind of sums you have to take like this. Mostly the competitive exam, they are asking in this method. So we feel that whenever the ratio comes, it is actually difficult, but it is very easy. Just to take the formulas and compare with the two values, you will find the unknown. It is very simple kind of questions here. Okay, so next one will move to the other formula, which is energy of electron in orbit. Energy of electron in an orbit. Okay, I think you people know the formulas. So energy of nth orbit is equal to minus 13.6 divided by n square z square electron volt. EV in the sense electron volt here. So this is the formula. Energy of nth orbit is equal to minus 13.6 n square z square EV. So whatever the orbit is given, you can substitute E5. Then E5 is equal to minus 13.6 divided by 5 square z square EV. So this will be an enough. Is there any doubts in this? Easy only, right? Okay, energy is directly proportional to atomic number or inversely proportional to atomic number? Atomic number. I am asking for atomic number. Energy is directly proportional or inversely proportional?
I'm directly
Yes.
I'm
proportional.
directly proportional.
Yes, it is directly proportional and then inversely proportional to the square root of orbit number, which is E is equal to inversely proportional to 1 by n square. Okay, then let's come to the hydrogen atom. In a hydrogen atom, all the energy values have calculated already. The very important thing, we will see what we are going to do for hydrogen atom. So for hydrogen atom, let's take this as a first orbit. Okay, this is n is equal to 1. This is the first orbit, and this is n value is equal to 2. This is the second orbit, and this is n value is equal to 3. The third orbit, then n value is equal to 4. Then n value is equal to n value is equal to 5, and this is your infinite orbits. N is equal to infinite orbits. Remember students, for example, I am taking an hydrogen. The hydrogen has one electron in the orbit. It should be in the first orbit. Am I right? So according to the ground state configuration, the one electron should be present in the first orbit. But whenever an atom absorbs electron, even this electron, the electron in the first orbit can move to the fifth state, or can move to the 8th orbit, or can move to the 10th orbit. It is according to how much energy the electron is absorbing. Okay, it does not mean that always the electron will stay only in the first orbit. Okay, the electrons will stay in the first orbit whenever the energy is low. But if the energy gained, the electron is gaining some energy, means it will move to the particular orbits according to the energy which is absorbed by the electron. Okay, so the value, the energy 1, the first orbit has an energy of minus 13.6 electron volt. Previously, we wrote one formula, energy is equal to minus 13.6 z square divided by n square. According to that, they have calculated all the first orbit have, for hydrogen atom I am saying, for the hydrogen atom, the energy of first orbit is minus 13.6 electron volt. If you do for this second, this E2 will be equal to minus 3.4 electron volt. Then the third orbit has, it is, okay, yes, let's write some values, some x values. So if you put the values over there, you will get the answer. So E1 is minus 13.6 electron volt, and E2 is minus 3.4 electron volt. Now the hydrogen atom, the electron in the first orbit, it has to move to the second orbit, correct? Then what it will do? It will absorb energy or it will lose energy?
Ma'am, it will absorb.
Very good, it will absorb energy. Okay, how much energy it will absorb? Any idea? How much energy will absorb? So very simple. So the difference between the first and second, okay, that much of amount of energy is needed to travel from the first orbit to the second orbit. So minus that, your higher energy state is minus 3.4. So it's a minus 3.4 plus 13.6, minus 13.6. That will be your delta E. So delta E is your 10.2 electron volt. So the electron in the first orbit has to move to the second orbit, means it has to absorb how much energy? 10.2 electron volt amount of energies. So simply it is equal to the difference in the energy levels. For example, this is your E5. Let's consider E5 value as a Y. Okay, the electron in the first orbit. The electron has to move from first orbit to the fifth orbit. Then how much energy it will absorb? Delta E is equal to, which is your E5 minus E1. So the difference in energy it has to absorb. While it is coming to the ground state again, the same amount of energy it will releases while it is coming to the ground state again. So always in the excited state, the atoms are not stable or the electron is not stable. So again it will come to the ground state by releasing the same amount of energy. Clear, students? Is there any doubts?
மேம்
Yeah.
இன்னும் ஒரு வாட்டி சொல்லுங்க மேம்.
Yes, okay. See, நம்மளோட எலக்ட்ரான் இங்க இருக்கிற எலக்ட்ரான் எனக்கு எங்க போகுது? செகண்ட் ஆர்பிட்க்கு போகுது. ஃபர்ஸ்ட் ஆர்பிட்ல எலக்ட்ரான் செகண்ட் ஆர்பிட்க்கு போகும்போது இதோட டிஃபரன்ஸ் இன் எனர்ஜி நீங்க பாத்துக்கணும். ஓகே, இஃப் யூ கால்குலேட் த டிஃபரன்ஸ் இன் எனர்ஜி, தட் மச் ஆஃப் அமௌண்ட் ஆஃப் எனர்ஜி இஸ் அப்சர்வ்ட். எனக்கு இப்போ minus 13.6 எலக்ட்ரான் வோல்ட் இங்க இருக்கு, minus 3.4 எலக்ட்ரான் வோல்ட் இங்க இருக்கு. இதோட டிஃபரன்ஸ் நான் கால்குலேட் பண்றேன். எப்படி கால்குலேட் பண்றேன்? டெல்டா E is equal to E2 minus E1. So high energy state minus lower energy state. அப்ப எனக்கு என்ன ஆன்சர் கிடைக்குது? 10.2 எலக்ட்ரான் வோல்ட். ஸோ அந்த எலக்ட்ரான் வந்து ஃபர்ஸ்ட் ஆர்பிட்ல இருக்கிற எலக்ட்ரான் வந்து அந்த 10.2 எலக்ட்ரான் வோல்ட் எனர்ஜியை அப்சர்வ் பண்ணிட்டு செகண்ட் எனர்ஜிக்கு போகுது. ஃபார் எக்ஸாம்பிள் N1 எனக்கு N5க்கு போகணும்னா இங்க இருக்கும்ல டிஃபரன்ஸ், இங்க இருக்கிற அந்த எனர்ஜி கேப்ஸ், இந்த எனர்ஜி கேப்ஸ்ல இருக்கிற டிஃபரன்ஸ் ஆஃப் எனர்ஜியை அப்சர்வ் பண்ணிட்டு இட் வில் மூவ் டு த ஹையர் எனர்ஜி ஸ்டேட். கிளியர்மா?
மேம் லாஸ்ட் ஆர்பிட் ஹையர் ஸ்டேட் ஆர்பிட் வந்து ஸ்டேபிளா இருக்கும்போது எலக்ட்ரான்ஸ் எல்லாம் ஜம்ப் பண்ண முடியும்.
ஹையர் எனர்ஜி ஸ்டேட் வந்து ஸ்டேபிளாகவே இருக்காது. ஆக்சுவலி என்னன்னா, லைக் ஒரு அட்மாஸ்பியர் எடுத்துட்டீங்க அப்படின்னா அது என்ன பண்ணும்? எங்கேயாவது அதுக்கு எனர்ஜி கிடைக்கும், சம்ஹவ் எனர்ஜி கிடைக்கும் போது அது என்ன பண்ணுது? அப்சர்வ் பண்ணுது. அப்போ அந்த அப்சர்வ் பண்ண எனர்ஜி என்ன பண்ணணும்? அது எதுக்காவது யூஸ் பண்ணணும். அப்போ அந்த அப்சர்வ் பண்ண எனர்ஜியை யூஸ் பண்ணிட்டு எக்ஸைட்டட் ஸ்டேட்டுக்கு போகுது. எக்ஸைட்டட் ஸ்டேட்டுக்கு போயிட்டா உங்களுக்கு என்ன ஆகுது? ஜாஸ்தி எனர்ஜி ஆயிடுது. ஜாஸ்தி எனர்ஜியில் எலக்ட்ரான் ஸ்டேபிளா இருக்குமா? இருக்காது. அதனால அகைன் என்ன பண்ணுது? அந்த எனர்ஜியை வந்து ரிலீஸ் பண்ணி மறுபடியும் ஃபர்ஸ்ட் இருந்த இடத்துக்கே வந்துடுது. யூஸ் பண்ண எனர்ஜியை வந்து ஸ்பெண்ட் பண்ணிட்டே இருக்கு. நம்ம ஃபுட் சாப்பிட்டுட்டே இருக்கோம் அப்படின்னா we have to do some work. நம்ம ஒர்க் பண்ணாதான் நெக்ஸ்ட் வீக் அகைன் we can eat, right? ஸோ அது மாதிரி அப்சர்வ் பண்ணுது எனர்ஜியா, இட் மூவ்ஸ் டு த ஹையர் எனர்ஜி ஸ்டேட். ஹையர் எனர்ஜி ஸ்டேட்ல இருந்து அகைன் லோவர் எனர்ஜி ஸ்டேட்டுக்கு வரும்போது அந்த எனர்ஜியை ரிலீஸ் பண்ணிடுது. எனர்ஜியை ரிலீஸ் பண்ணும்போது இட் இஸ் மோர் ஸ்டேபிள். Is it clear or any other doubts?
No doubts ma'am.
Okay, yeah. Very simple. அந்த எனர்ஜி கேப்பை வந்து அப்சர்வ் பண்ணுது. ஸோ நான் வந்து ஒரு பிளேஸ் இங்க இருக்கு, இங்க நான் போறேன், இங்க வந்து 5 கிலோ ஜூல்ஸ் இருக்கு, இங்க வந்து எனக்கு 10 கிலோ ஜூல்ஸ் இருக்கு. நான் இந்த பிளேஸுக்கு ரீச் ஆகிறதுக்கு நான் என்ன பண்ணணும்? 5 கிலோ ஜூல்ஸ் அமௌண்ட் ஆஃப் எனர்ஜியை நான் அப்சர்வ் பண்ணணும். ஏன்னா டிஃப்ரென்ஸ் இன் எனர்ஜி லெவல்ஸ் உங்களுக்கு எவ்வளோ இருக்கு? 5 கிலோ ஜூல்ஸ். ஸோ வி ஹாவ் டு இன்டேக் ஃபுட்ஸ் ஆர் வி ஹாவ் டு absorb some energy from the atmosphere, like 5 kilojoules of energy and absorb panana, I can move this place. So in the place poitu, again while coming to the same state, you have to release the 5 kilojoules of energy. It is very simple. Okay. Hope it's clear. We'll move to the next one. Ionization energy. Yes. What is ionization energy?
The amount of energy required to remove one electron, ma'am.
Very good, superb. A very important statement. This ionization energy you will be dealing with class 11 as well as class 12. So ionization energy, or we can say ionization enthalpy, or sometime ionization potential, all those are the same words. Ionization energy, enthalpy and potential. It is simply energy is needed or required, energy required to remove an electron from the valence shell. So we have an exact definition, like the exact definition will be in the gaseous state, and gaseous state you have to remove the electron from the atom only in the gaseous state. So that the definitions you can go through your books. So this is what the ionization energy simply. Energy is how much energy is needed to remove an electron from the valence shell. This is your ionization enthalpy. So this ionization enthalpy will be always equal to the energy of the first shell. Okay, it is simply equal to the negative of equal to the energy of the first shell. This is what they are saying. For example, let's take the E first shell. So for an hydrogen atom, what is the value? Or for any other atom means, let's consider minus 13.6 z square. Okay, this is a first orbit. So I already told you there are infinite orbits. No, the infinite orbit, the energy of the infinite orbit is how much? Equal to 0. Clear, students? What is an energy of infinite orbit? 0. Infinite orbits, there are many. Even if you take an hydrogen, hydrogen has infinite orbit, but the electrons is present only in the first orbit. Okay, so you are taking an hydrogen, you have considered as you took hydrogens. From the hydrogen you are removing an electron. Okay, from the hydrogen you are removing an electron. So the electron will move to where? It will move to the infinity orbit. Okay, it will move to the infinity orbit, means at the infinity orbit, what is the energy of electron at the infinity orbit? Yes, at the infinity orbit, what is an energy of the electron?
Zero.
It is 0. Okay, that's all. It is very simple. It's 0. So I need to calculate the value of ionization enthalpy for an hydrogen atom. Let's take a hydrogen atom itself. Yes. So ionization energy is also a delta E, which is your E infinity minus E1. Okay, because I'm taking an electron from the first orbit and I'm going to put in the infinity orbit. So this is the energy is needed to remove an electron and thrown it into infinity orbit is your ionization enthalpy. So the infinity orbit is how much? Which is 0 minus of, what is an E1 value? The E1 value is minus 13.6 z square. This is your infinity orbit. Then what is your delta E? Then your delta E or ionization enthalpy, which is equal to minus into minus plus, so plus 13.6 z square. Okay, this is your ionization enthalpy. So ionization enthalpy is always equal to the negative of first energy value, first shell energy value. So this is what you got finally. So this is about ionization enthalpy. Next, let's come to excitation energy. All those things are very similar. Excitation energy. What is mean by excitation? Anyone, will you tell me what is mean by excitation?
The amount of energy required for an electron to move from one shell to another, ma'am.
Very good, very good. The amount of energy is needed to move from the lower energy state into higher energy state. Excitation always will happen for the lower energy to higher energy state. See, let's take a basic example I'm giving. I'm not giving a very exact value, just basic. Here, let's take n value is equal to 5. And this is n value is equal to, this is n value is equal to 1 and this is n value is equal to 5. Okay, here let's take, this is in the 100 joules. Okay, let's imagine the first orbit has 100 joules. Okay, and this is your fifth orbit. Let's take, this is your 250 joules. Okay, now tell me, you have a one electron here. The electrons has to move to the fifth orbit. Then how much energy it's needed?
150 more joules, ma'am.
150 joules.
150 joule.
Super. It's a 150 joules. Very simple. So like, உங்களுக்கு understand ஆகணும்னா I gave as a simple example, like simple values. So ஒரு எலக்ட்ரான் வந்து first orbitல இருக்கு. First orbitல இருந்து fifth orbit போகணும்னா இதோட difference எவ்வளோ இருக்கோ அதை அப்சர்வ் பண்ணணும். Correct. It has to observe. Okay, the same amount of energy has to observe. So எனக்கு first orbitல இருக்கிறதுக்கு 100 joules இருக்கு, fifth orbitல 250 joules இருக்கு. அப்ப நான் என்ன பண்றேன், this is my E2 value and this is my E1 value. What I am doing, I am simply doing E2 minus E1. So what is your E1? E1 is your ground state. Okay, what is the E1 is your ground state. What is your E2? E2 is your excited state. Right, this is your excited state. So what is meant by excitation energy? Very simple. The energy is required to excite an electron from the lower energy to the higher energy state. This is what your excitation energy. So how can be calculated? The value of higher energy state minus lower energy state. You will get the value. I'll write the statement. It's clear, right? Anyone of you have doubts? யாருக்கு doubts இருக்கோ you can ask. Don't need to hesitate. ஏதாவது doubts இருந்ததுன்னா கேளுங்க.
10ஆம் வகுப்புல படிக்கிற அந்த பாடம் வந்து
clear, everyone clear?
போற வரல ஏதோ ஒரு பரீட்சையில கேட்டுட்டே இருப்பாங்க.
Okay, so yes, very good. Excitation energy. So excitation energy நம்ம என்னன்னு சொல்றோம்? So energy needed, energy needed to excite an electron from lower energy state. From lower energy state. From lower energy state to higher energy state.
Equivalent of getting 100 out of 100. So on the mark.
Higher energy state. So this is what called as excitation energy. And what is the formula actually for this? Very simple. Delta E is equal to E2 minus E1. So it should be important that higher energy state should come first. E2 minus E1. So this is your higher energy state. Higher energy state minus lower energy state. Okay, higher energy state minus lower energy state. So let's write according to the formula. Okay, so let's take E1. So what is an energy formula? Minus 13.6 Z square divided by N1 square Z1 square electron volt. And what is our E2 value? E2 value is minus 13.6 Z2 square divided by N2 square electron volt. Right, this is our formula. Then what is the next one? So the next one is delta E, which is your E2 minus E1. So E2 is given and E1 is given. Just substitute. The common term will be cancelled out. So your value finally will be 13.6 Z square 1 by N1 square minus 1 by N2 square. Okay, here Z1 and Z2 you no need to put because Z1 and Z2 are common. You are doing for the same atom, right? So it is Z square, Z square. So 13.6 Z square of 1 by N1 square minus 1 by N2 square if you subtract the E2 minus E1. So based on this formula, you can just directly put the values, N1 value, N2 value, atomic number value, and you can calculate it very simply. Is there any doubt, ma, in this?
We have two exams.
No, ma'am.
One exam
Okay,
is
yeah.
exclusively for
Next is very
mathematics.
important. Let's
ஆமா
come to
இன்னொன்னு
the
வந்து சயின்ஸ் அண்ட்
spectrum.
சோசியல் சயின்ஸ்.
Okay,
இவங்க
what does the
எல்லாருமே எங்க
spectrum
கோட்டை
mean?
விடுவாங்கன்னா இந்த சோசியல் சயின்ஸ் தான் கோட்டை விடுவாங்க.
Yeah, yes, basic definition.
Ma'am,
This I have been observing for the last 25 years.
white light
25 years
getting
பார்த்ததுல எனக்கு கண்டுபிடிச்சது வந்து சோசியல் சயின்ஸ் ஈஸி.
split into different light.
Very good, super. So white light, when a white light pass through the prism, it will splits into 7 colors. That is your with JR. If you record it in a photographic plate, you can see the all colors. That is what simply called as spectrum. Okay, what is what's the exact other meaning of spectrum? What it is? Splitting of white light, we can say.
Dispersion of light.
Yeah, dispersion of white light. Okay, dispersion of white light. Okay, very good. So like what will happen, you have a white light, you are passing the white light through a nickel prism. Okay, this is your prism. Okay, so what will happen, it will starts to split, the white light will starts to split. This is our white light, so it will splits into 7 colors. So Vibjia. So now you have some photographic plate here. So all the 7 colors will be seen in the photographic plate. Okay, all these 7 colors will be seen in the photographic plate. So the splitting of white light is called as a spectrum. Okay, photographic plate. Okay, this is your spectrum. Then the spectrum has a different range of wavelength. Electromagnetic spectrum, I think you people learned about electromagnetic spectrum, right? What is an electromagnetic spectrum? Do you remember what is electromagnetic spectrum? That is a collection of radiation of different wavelength. So like in the book, I think hope in the CBSE book and NCRT book, NCRT as well as your state board book, you have a electromagnetic spectrum in which the visible spectrum alone, it's given in color, others are actually it's not in the color, it's a black and white. That means we can see only the colors, we can see the colors only in the visible region. Others are black and white. All these radiations are arranged either based on the frequency or based on the wavelength. Like you have an X-ray, gamma ray, infrared ray, and then far infrared ray. So all those things are arranged here. Are then FM radio waves. All those things are arranged here. That is what electromagnetic spectrum. Spectrum in the sense, it's a collection of radiation. Okay, it's a collection of radiation. Collection of radiation of different wavelength. Of different wavelength. This is your spectrum denotes. A very small region has visible spectrum. The visible spectrum is with JR. When white light falls into the prism, it will split into 7 colors. Okay, there are many types of spectrum. We'll see all those in detail. Okay, so first, spectrum classification. Okay, classification of spectrum. First point, absorption spectrum. Okay, absorption spectrum. Okay, what does it mean by absorption spectrum? Any idea?
Spectrum that absorbs energy, ma'am.
Very good. The spectrum will not absorb energy actually. Some substances will absorb some radiation. So that can be recorded in a photographic plate, means this is called as absorption spectrum. For example, let's take a white light. Okay, here I am passing the white light through one solution. Okay, this is our solution. So let's take that this solution is observing blue color. Okay, blue color and then green color. The solution is observing. Okay, observing only the blue color and then green color. You know the pattern of JR. So only the solution is observing the blue and green color. Now the remaining colors are passed into the prism. So remaining colors are passed into the prism. Now you are recorded in a photographic plate. Okay, so now let's take, this is your violet actually. Okay, this is your violet color, and this is your indigo, violet, indigo, this is blue, this is green, this is your yellow, orange, and then red. Okay, so why I put dots for blue and green? Will you tell me why it is a dots? Why I put dots on the, instead of writing blue and green, why I put dots over here? Just see the solution. The solution is absorbing what color?
Blue and
It
green.
absorbs blue and green,
Blue and
it does
green.
not reflects blue and green.
Yes. So imagine you are observing something. Definitely that will not be recorded in a photographic plate, because as you observe that, it cannot be reflected in a photographic plate. So white light we are passing into the solution. The solution is absorbing blue and green color. Then the remaining colors, then again a white light, maybe again it is a white light. That white light you are passing into the prism. It shows other colors other than the blue and green, because the blue and green is absorbed by the solution. That means here you can see a dark spots on the background. Okay, a dark spots on the photographic plate, as the solution is absorbing blue and green. So dark spots on the photographic plate. So like understand, whenever a absorption spectrum, whatever a solution or a substances or whatever it is, a material absorbs some radiation, means that space will be an empty, or that space will be a dark spot if you seen in the photographic plate. Okay, it's a dark spot on the photographic plate. This is your absorption spectrum. Next let's come to the emission spectrum. Okay, so emission, you know the meaning of emission. Emission spectrum, the same thing we'll consider. I am passing the white light, so the solution is absorbs blue and green color. Okay, again it will absorb blue and green color. Then it is an emission spectrum, not absorption spectrum. Okay, so the solution is emitting the colors. So what color it will emit? It is emitting the colors. What color it will emit? It will emit the what color it is observed. So உங்ககிட்ட என்ன இருக்கோ அதுதான் நீங்க emit பண்ணுவீங்க. Am I right? Whatever you will have, that only you will emit. So what color the solution has now? What color? Blue and green. So you can see only blue and green. Okay, this is a blue color and green color. Okay, so when the substance is absorbing blue and green, means if it is an absorption spectrum, you can see the dark spot for blue and green. If it is an emission spectrum, the solution is absorbing blue and green, so that you can see only a blue and green in the photographic plate. Are you clear? Because whatever the solution is observed, that colors only it will emit, right? So it is emitting in blue and green. Am I correct, students? Is there any doubts here?
No, ma'am.
No, ma'am.
Okay, so here you have a dark spots on the colored background, either photographic plate or the dark spot on the colored background. Dark spot on the colored background. Background is already colored, but as the solution is absorbing some spots, that spot is a very dark for in the absorption spectrum. But in the emission spectrum, what will happen? No. So here colored lines in a dark background. Colored lines in dark background. So this is for the emission spectrum. Okay, so absorption spectrum is already a colored. If a solution is absorbing blue and green, means that particular area will be a dark spot. in the emission spectrum, the photographic plate is actually a dark. The emitting colors are blue and green. So you can see only the blue and green lines. So it's a colored line in the dark background. Okay, now let's move to the different types of emission spectrum. This is also very important. So first one is continuous spectrum. Okay, in the emission spectrum, there are some example, some sub-classifications. It's a continuous spectrum. Continuous spectrum in the sense you cannot differentiate the colors. Can't differentiate the colors. Give me one example for continuous spectrum. We can't differentiate the colors, like where the violet ends or where the indigo ends. Will you people can say in WebGR? It's not possible, right? In the rainbow, will you say that the red color ends here or the red color starts here, the blue color starts here? Is it possible to say that? No, there is no exact line. It merges. Am I correct? The next colors are simply merges. So it's a continuous spectrum. So we can't differentiate the colors. We can't differentiate the colors. Okay, because it's merged together simply. We can't differentiate the colors. It's somewhat merged. The next colors are merged. It's a continuous spectrum. Then tell me about the discontinuous spectrum. Of course, it will be an opposite of it. Yeah, what is a discontinuous spectrum? The colors
can be differentiated.
Yes, the colors
we can differentiate the colors, ma'am.
Very good. We can differentiate the colors. So it will not merge together. You can differentiate the colors. Okay, discontinuous spectrum. We can the colors can be differentiated. Can be differentiated. So this is for your discontinuous spectrum. Then again in the discontinuous spectrum, there are two things actually. So one is your band spectra. What is it? Band spectra. Okay, this band spectra, only molecules will show band spectra. You know the difference between a molecule and atom, right? What does mean by molecule?
One or more atoms combined to form a molecule.
Very good. One or more atom. Either it may be a same type of an atom or a different type of an atom. The band spectra can be shown only by the molecule. So molecule only show band spectra. Okay, band spectra or a spectrum. Band spectra. Okay, how it looks like exactly means this is your photographic plate. As it is a band spectra, you can see a dark bands over here like this. Okay, this is what called as band spectra. Simply it's like a many lines together. Okay, many lines connected together means it will look like a broad line. No, similarly we can say it's a broad line as a band. Okay, this is a band spectra. This is your band spectra. Then the second one is your line spectra. The second one is the line spectra. This is actually this is your photographic plate and you can see the individual lines. So it's very simple. Here atoms will show this spectra. Okay, single atom will show this line spectra. You can see an individual lines. So it's a discrete lines, a separate lines. Discrete or fixed, we can say. Discrete lines. This is what called as a line spectra. Band spectra means like too many lines connected together means it will form a band that is created only by the molecules. Because of the molecules, the band spectra is formed. What does mean by line spectra? Line spectra in the sense a single line is formed like this. This will happen only if you take atom. So the atom will show the line spectra. The band spectra will be shown in the molecule. Is there any doubt, students? Are you people clear? Is there any doubts?
No doubts, ma'am.
Okay, yes, fine. So next we have an hydrogen spectra that we will see in the next classes. Okay, before that, I'll ask you some basic questions. Okay, So today's class is about the spectrum. What is a spectrum? See, spectrum in the sense, what is a where they have used spectrum means, the X-ray. We have to take an X-ray for like just to scan the bones or the teeth. Also, we can take the X-ray. So just to find the what is happening either in the body or in the atom, they used to call as a spectra. The spectra will be most useful to find out the unknown substances. For example, a scientist is studying about a new chemicals. They are preparing a new chemicals means by using the spectra values, they'll find out this is a substances and this will be used for this, and these are all the some advantage of this, and these are all some disadvantage of this. So they'll be get into some conclusion from that. Okay, this is a main use of the spectra. For example, like let's take a tablet, a paracetamol. So they will be using like NMR spectroscopy or the IR spectroscopy. These are all the instrumentation names. IR, NMR. I think some of the ad shows NMR spectroscopy for honey. For honey, they showed one of the ad NMR spectroscopy. From that, they will check the purity. So spectra, in the sense, we can know about many things of a new one. Like electron is very new at that time. Correct. Electron is very new and it is a very smaller particle. We don't know much about electron. So based on different spectroscopic techniques, they are saying atom is this. It will absorb, whenever it will absorb energy, it will move to the excited state. So based on this, they are saying the characteristics of an atom. Okay. Yes. What is an ionization energy? Any one of you?
The amount of energy required to remove one electron from an atom.
Okay. Yes. Excitation energy. What is mean by excitation energy?
The amount of energy required for an electron to move from an energy of lower energy shell to a higher energy shell.
Okay. So when the ionization energy will be equal to the energy of the orbit, what's the relationship between the energy of the orbit with the ionization energy?
Ionization energy is negative of energy of first shell.
Very good. Okay. It should be very, very important. It is a negative of the energy only if it is in the first energy state. Okay. Because second energy state and all, the value will differ. Okay. Only if the first energy state. Okay. So is that Bohr model is applicable for all the electron species?
No, ma'am, it's only applicable to single electron species.
Very good. It will be applicable only to the single electron species. Okay. So in the next class, we will discuss about the hydrogen spectrum, and then we have some limitation in the Bohr model. Why we want to shift the Bohr model to the quantum mechanical model, we will discuss in our next class. Okay. Thank you, everyone. People can leave.
Yeah. Thank you, ma'am.
Thank you, ma'am.
Thank you, sir.
Thank you.